This is one tough FRQ question. It comes from question number 6. A, you get 2 points for, and B, okay. And the average score on this question was 2. I think people got A, but B is a real tough one. Well, let me help you through it so you can pick up a question like this in the future without too much difficulty. Identify a compound from the table that can be dissolved in water to produce a basic solution. Let's do that first. Let's identify a compound that's going to make a basic solution. Now, before I get to this, if you have a good memory, you would have remembered in acid bases that the acid properties of salt solutions. In fact, I put this in because occasionally there's a question on this on the exam. And the way in which you find out if something's going to be acidic or basic is to follow these rules. Now, they sort of make sense. The first one says cross out any alkaline metal or alkaline earth metal ion. These cations are always spectators. These are soluble, and alkaline metals and alkali earths are pretty easy to remember. So let me immediately go here and get my cross-out tool, and I'll get this line and I'll make it red. I've got it. We're going to cross out the alkali metals. Here's sodium, here's potassium, and here's lithium. Of course, you have to know the alkali metals, but it's that first column. They pretty much don't react with anything to make acids or bases. They just act as spectators. I mean, you know that the potassiums and sodium ions don't react, are all soluble, so you figure that they're not going to react with anything to make a base. So let's go to those rules again. First, cross out any alkaline metal or alkaline earth ion. Good. Then second, cross out any ion from a monoprotic strong acid. Now we know the strong acids are HCl, HBr, HI, nitric, and in this case are chlorate. So I'm going to go back here and get rid of anything that is associated with a strong acid. Well, here's the iodide. It's associated with strong acids. This strong acid is completely ionized, and the iodide just floats around doing nothing. So that eliminates the iodide, and so all we've got left is the fluorides. And the fluorides, if you remember, HF was a weak acid, and then we could go from there. Now, another way of going this, if you didn't remember this, I mean, you've got a lot to remember in AP Chem. So let's say you forgot that, and you want to say, okay, how do I figure this out? And usually there's a way in which you can figure things out. First of all, we're going to make a basic solution. So you know you're going to be making hydroxide. And if you're going to be using an ion to make a hydroxide, then we've got a negative charge on this side. We're going to have a negative charge on that. So to make a hydroxide for a weak acid is we take a conjugate base, react it with water to make the conjugate acid, NOH minus. Now, this is something you should remember. This is how weak acids end up reacting, or I should say, weak conjugate bases react to make a basic solution. They hit this water molecule, and because they're not good at removing H's from themselves, they'll pick up the H, keep it, and the hydroxide is left over. So that means you know you're going to be using either the iodide or the fluoride, assuming you didn't know about these earlier things. Now the next thing is, okay, so this is going to be the fluoride ion or the iodide. Now the iodide makes HI, and you say, wait a second, that's a strong acid? No way. I mean, we don't have an equilibrium with a strong acids. They 100% react, and their anions just act as spectators. So that leaves behind the fluoride. In fact, here is that equation. And this makes sense. Fluoride ions produce HF, which is a weak acid. In other words, fluoride ions stick to H pluses and they don't fall apart. Only 9% of these HFs break apart. So that gives us our basic solution. So the weak acids produce conjugate bases that will produce weak bases. So there's our answer. Now let's look at their arrangement. they accepted either LIF or NAF as identifying the compound. So you have to choose the correct compound. Now, so you would have had to say, identify the compound. You could have said lithium fluoride, or you could have said sodium fluoride. Now, again, if you didn't understand this or whatever and couldn't figure it out, make a guess. It asks you to identify a compound for the table. So if you just picked any one of these, LIF or NAF or KI, you would have a 50-50 chance of getting the answer. So you get 1 point for picking one of these 4 compounds, and 2 of them are the right answer. So, sometimes if you can't answer a question, at least guess. In this case, you had a 50-50 chance. So 1 point is for saying LIF, NAF, identify a compound from the table. So pick one, period. It's better if you can pick the good one. Now, if you knew how to pick the fluoride, the net ionic equation takes the ion, especially the sodium fluoride would be a good one because it's totally ionic, totally soluble, and you'd have fluoride plus H2O making our base and HF. You had to have the charges right, and that's going to be a tough one to get, writing the correct balance equation. Don't forget to put the charges in here. By the way, if you would put down LIF, reacts with water, they would have accepted it too, because there's no way you would know that lithium fluoride is soluble, which is one of the flaws of this question. So, very, very tough one. If you understand this, you really are doing college level chemistry.